All right, so this is the 2019 that we're trying to solve here, 2019 number 3A. Right, we made a substitution for tan squared using this identity here, and we're solving for theta. Right, if you look at the range now, right, let's just do a quick little sketch, right? Remember, cos looks like this, right? So on the opposite side, it looks like that. So between negative pi and pi, it has two solutions. It has two solutions that are kind of equidistant from the y-axis. So if one solution is pi on 3, then the next solution should be negative pi on 3, right? So this little range, right, change the question a little bit. So it's important that you can sketch it properly, right? So the only two valid solutions are pi on 3 and minus pi on 3. Draw this, right? Draw this for cos theta between negative pi and pi, right? All right, let's check out the next one. Okay, so the next one here, you have to put it in the form, and you'll recognize again, they told you what form, right? So it makes it easier. R is equal to the square root of 1 squared plus 2 squared, which is root 5. And then we're just going to compare this to R, right? You don't have to write this line if you've seen it, if you've seen the comparison one time, right? R sine x cos alpha plus R sine alpha cos x, right? So it means that R cos alpha is equal to 2. So therefore, alpha is equal to cos inverse 2 over R. How much is that? Nice. So the final answer is f of x is equal to root 5 sine x plus 0.464. And so otherwise, find the general solution. So really and truly, they want us to find the general solution of root 2 sine x plus 0.464, right? Equal to 0. You'll recognize here, when you carry across the root 2, you'll get 0. So really and truly, is x plus 0.464 is n pi plus minus 1 to the n of, what is alpha? Alpha is what? Sine inverse 0, right? Sine inverse 0. Here's x plus 0.464. And last part, the minimum value is what? The maximum value for f is root 5. The minimum value for f is minus root 5. So therefore, just plug them in here. 2 over 2 minus root 5. 2 over 2 plus root 5. This value is the max. This value is the min. Okay? I guess you could even leave it like this, right? Right? Or you can simplify. You get 3 marks there. Right? You'll get 1 mark here. 1 mark here, 1 for substitution, probably. What was the answer here? Minus what? 8.47. Okay. Let us go again. Prove the identity. Right? I just break it on the right side a little bit, right? Just a little bit. Sine B all over cos A by cos A cos B minus sine A sine B. Right? So it might look like this. Sine B all over cos squared A cos B minus sine A cos A sine B. So we had to get that kind of funny looking thing on the left side. Right, so there's no need to probably expand out the denominator, right? Right, so really and truly, this wasn't really useful. So here is cos A by sine A cos B plus sine B cos A minus sine A by cos A cos B minus sine A sine B all over cos A plus B. Right, let's multiply out. Right, this will cancel with this, right? So that'll be sine B cos squared A plus sine squared A sine B all over cos A plus B. When you reach here now, you could factor out sine B. When you factor out sine B, you'll get cos squared A plus sine squared A all over cos A plus B. This value here is 1, so you'll end up with sine B all over cos A plus B. All right? Let's check out 22 now, right? Solve that fast. What's the maximum value for tan? No maximum value, right? Tan goes on to infinity and negative infinity, right? Just one symbol. Tan has a asymptote at 90 degrees and pi after that, right? If you try to find tan 90 or tan 270 for any value 180 after that, you'll get error, right? So what that implies is that we could find tan for any value, right? So tan inverse 3, first quadrant and fourth quadrant, here will be tan inverse minus 1. That will be in the second quadrant and the fourth quadrant. This one here is 3 pi on 4, 7 pi on 4, right? What is tan inverse 3? 1.25. And tan is positive in the third quadrant, so that's pi plus 1.25. All right, so these are your 4 answers. Okay, let's go again. See part 1 and 2. That's part 1. Show that 4 cos theta plus 3 sin theta is that. And then hence or otherwise solve that. Sorry there. I don't know where I got 5 from. Right, sorry about that. So it's pi minus 0.927. Right, so one answer is 2.1. Next answer is what? 5.36. Or leave out 0. Yes, and 0. Remember the graph? Sign is 0 here, here, and here. So yeah, just squeeze in the 0 from as well. Right, let's try 2017. If you choose to use the left-hand side, you'll end up with sine A plus B over cos A plus B, which is sine A cos B plus sine B cos A, all over cos A cos B minus sine A sine B. Here's the problem, right? The problem is I want to get 1 here. So what I could do is probably divide every single term by cos A cos B. And watch what will happen. This will cancel, this will cancel, this will cancel and give you 1. And then you'll end up with tan A plus tan B all over 1 minus tan A tan B. Right? So if you figure out how to get rid of the 1, you do it for all the terms and divide everything by cos A cos B. Next side, they told you that sine A is acute. What does that mean? It's in the first quadrant. Cos B, sorry, angle B is obtuse. So it's in the second quadrant, right? Right. So if we have sine A, it means we have opposite and we have hypotenuse. So if we look back at the last question, tan A plus B was tan A plus tan B over 1 minus tan A tan B. Work it out fast. Right, I got tan A to be 3/4. Right, then we use same triangle. B is obtuse. Right, I have adjacent and hypotenuse. Here's what, root 3, I think. So therefore, tan B is opposite over adjacent. So that's minus root 3 because it's obtuse, right? And then plug it in the formula. Tan A was 3/4. Tan B is minus root 3. Tan A is 3/4 multiplied by minus root 3. If you don't like the fraction, multiply everything by 4. And you will get 3 minus 4 root 3 all over 4 plus 3 root 3. What do you do when you reach there? You want the answer like this. Right. Multiply by the conjugate. Right, you rationalize. So that'll be 16 minus what? 16 minus 27, right? And then you work out the top and tell me what you get now. The answering box there, right? Solve that. Look at the range, right? Between 0 and 4 pi. pi and 3 pi. That's okay? Let's go again. Last part, all you. I use 9 marks. Wait. General solution this time. So r is equal to square root of 6 squared plus 8 squared, which is 10. And then we could expand it out and compare, right? Oh, by the way, I now realize working in degrees, not radians, right? Look at what they say alpha is here. So alpha will be, when you expand it, you'll get r sine theta cos alpha. So you're going to get alpha is cos inverse 8 over 10. How much was that? 36.9. Okay, nice. So therefore, f of theta is equal to 10 sine theta plus 36.9, right? And they want the general solution, right? They want the general solution for 10 sine theta plus 36.9 is equal to 2, right? When you're working out the general solution, right here is where you kind of stop, right? 2 and 10. And you're going to write whatever in the bracket, theta plus 36.9 is equal to, and here's where I write the general solution, n pi plus minus 1 to the n of alpha. How do you get alpha? You find sine inverse of this. And then you stop. What is sine inverse of 2 times? 11.5. So when I reach here to the top, right? If you go further and try to solve it, then that's not general solution anymore. Okay, so you can leave it like that, or you could say theta is equal to n pi plus minus 1 to the n, 115,